Our next speaker is Silke Holtmanns, who is a mom of 2 kids and has 3 cats. Loves to bake for her friends and does taekwondo, has a red belt as far as I know, and also likes hacking mobile phone networks, which is, I guess, the closest thing from those that I mentioned to the topic of the presentation. Silke is a security expert and does research on new attack vectors and mitigation approaches. She does data analytics, machine learning, and deals with privacy issues. Let's welcome Silke Holtmanns with her talk.
Thanks a lot for staying here so long. And I noted that, thanks to Marek for the nice introduction. I noted afterwards I was busy with something else, that I probably have chosen the most boring title for this presentation, sort of an abbreviation, some protocols probably nobody here knows or uses at all, or just as sort of on the rim. And I could have chosen something much more interesting, like how to hack a mobile phone network or things like that. Well, anyway, so nevertheless, you came here, so I'm very grateful for that, and I promise you some sort of insights in mobile networks, which you probably don't hear that often about, or if you now hear, you know what this is about and know some background. So, my background is in mobile phone technology, and I'm now with the networks part, and the work I'm doing basically affects everybody of you. I can say that everybody of you who has a 4G phone in his pocket has some work of me in his pocket. So let's start. So I'm in industrial research. What does that mean? So Nokia has an industrial research branch. And it's called Nokia Bell Labs. It's a quite old thingy. There were acquisitions and diversions and things like that. And in the end, Nokia bought Alcatel-Lucent, and the research merged there. So there we are, industrial research. What's the big difference to the university research? I was before a lecturer in mathematics at the university. I've held a PhD in mathematics, and that was too theoretical. I wanted to see my things fly. I wanted to really do something, solve real problem, not some esoterical stuff where you never know where it ends up. So I ended up in industrial research, and there we really look at what are the problems for the operators, sort of what are the attack possibilities. And then we go also public with those attacks and tell them to our customers. They are not always happy about that, but anyway, we do it nevertheless. And they give us feedback on, yeah, that might work somewhat, which means, we have a problem. Or they might say, yeah, that doesn't work because of this and this and this. Sometimes they just try to avoid the problem. We also had that. But some say, yeah, we need to do something. So we try also to find countermeasures and then feed them also back to the customers. And they say, yeah, that works, that doesn't work, and so on. So, and we also give that to product. So we have some products in the area, and the nice thing about industrial research, we really get to work on the pain points of real people and operators. So it's not just something sort of where you never know where it ends up. So we have a small team. Johan Miché is our machine learning expert. Ian is on privacy. And we try to find things that haven't been caught yet. Mobile networks are heavily under attack. You can say on the interconnection, I will later explain exactly what that means. It's between 0.5% and 4.5% traffic is strange, let's call it that way. We cannot sometimes not differentiate between a misconfiguration and a real attack. That's very difficult to know what's going on. And there's probably a lot of stuff that we haven't figured out exactly what's happening there. Also, we have to see sort of how we can counteract. And we also noted recently that telco protocols become more IT-like, so internet-like, and also we see more hacking, internet-style hacking in mobile phone networks. So these two worlds, the telephone network was something sort of very separate. They are moving closer towards each other. So we see programming tricks that have been done in early times of internet. We see them now in mobile phone networks. And so the attacks are evolving. That also means for us as a company and as individuals, we have also to evolve. We have to learn, we have to understand, and we have to find countermeasures. And we also have to educate. It's actually a big business to educate. Because mobile networks are very vulnerable, and they are a critical infrastructure nowadays. Think about how many connected devices there are. So, so we also talk to governments, we talk to operators, also to company internally. So one abbreviation I cannot spare you, that's SS7. What you need to know about it, it's the language two mobile networks talk to each other. That's the signaling system number 7, and that's when you, let's say, wherever you're from, want to talk to home, most likely this call is set up using signaling system number 7. So we are here. We are there on the top. Somewhere in the cinema, the arrow should go a bit more up because we are not on the bottom floor, but I didn't know that when creating the slide. So our phones are now connected to Vodafone or some other networks here locally. We have meeting attendees from Germany. They connect, for example, to Deutsche Telekom, to France, they connect to Orange, or from Spain to Telefonica, or from UK, they connect from 3. So we might even have some people from Russia with subscription from MTS, and they all switch on their phone here and it works. I'm from Finland, so I'm originally German citizen, but now I'm Finnish citizen. I have a Lisa subscription, my kids have subscription from Telia Sonera and DNA, and I can call them, and that's roaming. But think about it, why does it actually work? I mean, that's a question sort of people rarely ask, why does it actually work at all? I mean, these are different companies. The Polish network has never ever seen me before. It's the first time I set my feet on Polish ground, so I've never been here before. So how do they know that I pay my bills and I'm sort of creditworthy to give this service? Well, because they made a short brief call home and asked sort of, is this person sort of creditworthy and can I give service? And then home says, yeah, it's okay, she always pays her bill. Well, my company pays a bill, nice of it. Anyway, as far as the operator here is concerned, fine, they can give service. So this is happening via the so-called interconnection network. It's a network which connects all mobile phone networks with each other. And it's directly connecting the network. Some are directly connected, some are connected via roaming hubs. It's not the internet, but it has some touching points with the internet. So it's not exactly the same, but it's equally important. And why I make the claim that this is equally important, this sort of secret network that nearly nobody knows about it, and that's this. We have there all kind of connected things. We have a tablet, let's say in Alaska, connected to AT&T, connected Scale in California, connected to Verizon, Telefonica in Brazil. And we have here a gas meter from British Telecom that always sends sort of how much gas you have been using. Here in the bottom we have a fire alarm from Telstra in Australia, connected to Telstra. Assembly line and this kind of automation, factory automation, let's say in Japan or in China. And then we have clearly the classical mobile phones. And actually all those devices are connected to their operator, and this operator is connected to the interconnection network. It doesn't make a difference if they're moving or not. If I would send an SMS to a gas meter, it would arrive there. Or at least it would be sent there. I don't know if the gas meter would actually understand my SMS, but I could send it. So all these devices are reachable from the interconnection network. So therefore it's important to see that this is an important network, and to understand the security problems, because this is a security talk, we go a bit back in time to understand what this is actually about. So it was something like 35 years ago, or maybe even a bit more, when 4 operators decided to set up a fully automated cellular phone system. And they started with Finland, Sweden, Denmark, and Norway. And it was called Nordic Mobile Telephony Network, as my Finnish colleagues used to say. And actually, we have these kind of nice Talkman in the office. It's sort of this big and it's sort of extremely heavy. If it wouldn't be so heavy, I would have brought it here just for the fun of it. So they made roaming working. So great success. And actually, that was actually the most biggest problem, I would say. They knew each other. The companies were state-owned. They were knowing each other. They were sort of sitting together over a beer or two. And so they trusted each other. So they built a pipe. It worked. They sent messages, could set up call, and so on. So marvelous. But it had no inbuilt security because it was a closed network. So why inbuilt security? Nobody else than the good guys were in. Okay, yeah, well, it was a big success. Actually, too much of a success, because nowadays we have something like more than 800 operators, at least in it. We have IPX roaming hubs, which sort of, for example, if you make a call from here to, let's say, South America, let's say Brazil, your phone is most likely routed via Canada. At least one hub, probably more. There's probably no cable from Poland to, let's say, Tuvalu. That's an island in Pacific, very small, very tiny. There might be a cable from here to, let's say, Germany or Russia. So that might be, but for these kind of rare connections, there will be no direct connection. So there are roaming hubs in between. There is application to user SMS. You probably know that, reminder from the library, reminder from the dentist, password resets, and things like that. So there are application to user SMSs and many other more services. There are especially mobile virtual network operator for IoT, for example. And now the whole thing, most of it is still using this SS7 protocol. And now we move towards LTE, also for the interconnection, and to diameter-based protocol. That's a new protocol. So let's go back to the assumption. So the biggest security feature of the network, recall, was it was closed. And so let's have a look if this is really true. On the top, you see an European operator. I've chosen 3, but it's actually holding for all European operators. They have a wholesale business, it's called. Let's say you want to set up a business saying you want to provide a mobile virtual network operator for bicycles. I mean, these public bicycles are so on. So then you can go here to the Polish operator and say, I want to be an MVNO for bicycles. And he has no legal grounds to reject you that. It's an EU law. It's an EU law to encourage competition. So that the operators could not say, no, you are not allowed to do that, to avoid some competition. So the EU said you must sell this to the operator. So I put there 3, but actually it's an issue in whole Europe that if somebody comes with a reasonable plan, they have no reason to reject it. Another way to get into this perceived closed network is just to buy it on the darknet. I mean, this is here from the darknet, so you can buy cell phone interception for $199, SMS messages, I think it was for $350 for a month, if I recall correct. Location lookups, 3 location lookups, $150, sort of track your wife or girlfriend or whatever. So you can buy or you can just have access to the API, which is slightly more expensive, but still not out of range. Another way to get in is, for example, this here. This is a screenshot from Shodan. That's an IoT search engine. And here we have China Mobile. It's China Mobile, for those of you who don't know, it's the biggest operator in the world. I think the last time I looked, they had something like 800 million subscribers. So something not exactly small. ZTE, it's a competitor of us. Mobile network equipment manufacturer. And this here is actually the critical term, GGSN. That's a mobile network node. You don't need to know what it's doing or anything else. I just tell you, this node is not supposed to be on the internet. It's not doesn't have any sort of technical reason to be on the internet. But for some reason he is. Let's hope it's a honeypot. Let's be optimistic, it's a honeypot. Maybe somebody just put an Apache web server on it and wanted to stream to his friends some, I don't know what. So you find things which are not so close as you think, and obviously this has also been used. On the right hand side you see the top one is the GCHQ, breaks my tongue every time. So these are the British spies. They hacked the Belgian operators. Belgacom is a state-owned Belgian operator in 2013. Below this nice beautiful map with a lot of green inside, that's from the NSA WikiLeaks. Countries where they hacked the phone network. So I think Poland is somewhere sort of yellowish, if I recall correctly. Yes, it is. Yeah. So it's sort of medium. Africa is completely green, or nearly completely green, sort of, yeah. So that is from Auragold, that's the WikiLeaks, yeah. And also the NSA was leaked that they have the drone programs. You might have seen sort of that some houses have been shot by drones and so on, and actually it was leaked that something 70% of the data they use for target acquisition is coming from mobile phone networks. And which is actually really, really bad, because I mean these are mobile phone networks. They are made for mobility. If you move from A to B, they are not made for target acquisition and things like that. And also the data is not good enough for this kind of purpose. So it's not the right idea. So, but that's how it is. So how do attackers get in? They rent it as a service. If you're really lazy, you just go darknet buy it. You hack your way in. I mean, you can just basically find these nodes like I did, and then see sort of, okay, do they have telnet port open? Do they have the FTP port open? Do they have default admin usernames and things like that? So, or you just can have the power. In some governments, you just need to find one weak point. In some governments, well, I mean, if the guys kick in the doors and say they want to have access, or say you are not allowed to use your network next year, I mean, what could people do? It's a bit challenging. Of course, you have the classical way of just bribing somebody. I mean, well, money always works. You can become an operator in EU, for example, or you can do classical social engineering. Of those, we have also seen some cases, very cute, also working to some degree. Okay, since we don't have internet connection here, actually I wanted to show you how to do that. So, but due to that the internet connection here wouldn't be reliable, so on, basically say sort of what can be done. So you can go to Shodan.io, search for nodes like this GGSN, or look for Sigtran ports. Sigtran is the IP version of SS7. So our diameter ports that are open. Then you see, and then you look, okay, which of these nodes displayed are mobile operators? And there you go. And based then on that, you start sort of normal hacking, meaning you just download the tools for password cracking or similar. So it's not really rocket science. You can buy access, for example, a hacking team. It's an Italian hacking company. They were caught red-handed when they sold software to UN embargo companies, but they're still in business as far as I know. I think they just got a slap on the finger and everybody looked away. You can also wholesale, I mean, just Google for the fun, wholesale interconnection access. Just now, use your phone, search for it, and I'm pretty sure you will at least find 3 or 4 operators. Just like this. Getting the thing technical running is a bit more challenging, but still, it's possible. And if you want to know how to find your targets, sort of, where do I send the messages? Well, there are roaming documents, they're called IR21, and the operators use it with each other to communicate how to set up the networks and so on. And actually many of them are leaked. They shouldn't be there, but they are leaked. Because some of these operators are pretty careless about them, because they wanted to share it with some other operator, and so they just put it up on SlideShare or things like that. We try to hunt down as many of these documents as possible, so to reduce the amount available publicly. So, yeah, we don't want to. So, just as a homework, you can see that. Have some fun and browse a bit the internet. So after I've been talking about sort of how to get in, what do we do now once we are in? Okay, we can do many interesting things. We can do location tracking. That's on cell level. Means there are some tricks to get pretty accurate. We can actually search in the interception of cells. So we get a quite accurate location tracking. Eavesdropping of calls, at least for older networks. Fraud, so we can set a prepaid subscription to a postpaid subscription with no limit. That's very nice. You don't need to worry about topping up. Denial of service is easy. Denial of service on a particular user is really easy. Network is a bit more tricky because you need to know how much resource the network has for something. Credential theft, that means you each have in your SIM card a cryptographic key to protect your communication. And these keys are sent in plain text over the interconnection network. Yep, they are. So, yeah, and I can request them. So they are not just sent, you can intercept them, you can even request them. Sort of, it's a feature. We work on that, yeah. So this is not really sort of the most safe approach, let's call it that way. SMS interception is actually from, well, data session hijacking, that's GTP, that's a different protocol, but I put it still in the list. Blocking of stolen phones, that's an implementation-specific attack. We informed the vendor that we found a bug in their equipment identity register. I think they fixed it, because I know the guys quite well, so I think they fixed it. SMS interception, which is from a user perspective probably one of the very worrisome thing, and also because there's money behind it. Because there are all these one-time password things like Facebook, WhatsApp, Gmail, Twitter, and so on. By the way, Trump doesn't have a phone number associated, so with his Twitter account I would have loved it. Anyway. So there are all these password reset using SMFs, also Microsoft, our own email servers using it. Yeah, anyway. So there are good reasons, and for SMS you can on YouTube find a video how to do that. So yeah. As said, the main security feature of the SS7 network was that people couldn't get in, but that's, as said, it's no longer true. Okay, what's the status of the IPX security? We already sort of touched this a bit. Sort of the most commonly used protocol is the SS7 MAP protocol. Often you have intermediate nodes, which makes it extremely difficult to figure out where the attacks are actually coming from. I have no clue sometimes. Most of the time actually I have no clue where the attacks are coming from, because they can also just be routed and proxied and whatever. And very often there's no form of transport security as said. There might be a direct cable between operators which have a lot of traffic, but for many, as said, sort of to Pacific Island from here, well, it's not worth putting a cable in. So there will probably be no security on those routes. So no IPsec, no TLS, no datagram TLS, no MAPsec. So meaning no source authentication, no integrity, no confidentiality, and also no route tracing. I left that out. So that's where we are. So now the new protocol is coming, yeah. All will be better. Well, different. Yeah, that's how life goes. So we get a new, it's like getting with these new tools for communication and setting up phone conference. Everybody is sort of promising, oh, it will be better with the new communication tool. And then you start using it and it's like, okay, it's just different. Just different tools, same mess. So let's see, sort of on the attack side, sort of who is using it and why. Intelligence community, they see it as a sort of all-you-can-eat buffet and for whip trapping and eavesdropping. There are service companies out there that sell to governments. They make money out of that. So, and also military, as already mentioned, they use it for target localization. So why should those guys stop suddenly? Because just we have a new protocol? I mean, come on. They just go with technology, like these guys. These guys is, that's a governmental service company, which offers all kind of services for governments and sort of critical infrastructure provider, and they are sitting in the United Emirates. And there have been some interesting stories around about their acquisition techniques, and sort of they try to hire security experts and how they do it. So they're quite some fun to read. There are some people sort of posting their job interviews on the internet, so very interesting. And they become now a GSMA member, which means they have access to a lot of data from operators. So they move with time and technology. They are very customer oriented and they know what they do. So I cannot avoid this. I have to tell you a little bit about the mobile phone network. So you see here on the left hand side, you see all kinds of devices, phone, tablets, whatever, connected to the antennas. Then you have the HSS, that's the database. There it's basically your phone number is stored there, your cryptographic keys, if you have a prepaid or postpaid, your location is stored there, and so on. Then we have the mobility guy, that's the one with the MME. So this guy takes care when you move from one area to another area. Then we have the watchdog at the corner of the operator network. That's called diameter edge agent. That's basically, I think in the original had some clouds actually there. So basically this here is one operator network and that there is another operator network. I'm afraid I lost the clouds when I copied this over from another presentation. So these are connection between two operator networks. In the middle we have an IPX provider. That's this kind of interconnection provider to connect, for example, to countries. Tata Communication is such an IPX provider. So as said, if you call from here to Brazil, it would go via Canada, for example. And in Canada with some guy sitting, that would be the guy in the middle. Actually, it's fun on the screen. I have the clouds, but not on that. So probably too light. So this is sort of how a very, very, very high level description about connection between two operators. So this is about a bit more beefed up example. So how it looks like when you have, let's say, 5 operators there. And what you see there is in particular that you have between operator A and operator C, you have actually 2 routes. So which means that if I send a message from operator A, let's say I have an SMS here which I want to deliver to this operator C, it can either go directly via IPX provider 1 or it can be going over the IPX provider 2. And that might change constantly. Also it might be on the way to and back different routes. And that depends on money, usually. So it's a big market about prices of interconnection providers and sort of there's always a data flow and a money flow involved. So it depends on load and things like that. So you never know exactly the routes of the communication, and it's also afterwards you cannot actually, in most cases you cannot see where the message has been going through. So it just goes somewhere and arrives most of the time. So this is now 4 or 5. Imagine that something with 800 parties, and it gets very funny. So I don't even want to think about how many lines I would need to draw if I want to set up something like that with 800 parties. So which attacks do we have are known with the new protocol type, which means diameter, which is used for 4G and 5G. So we know that location tracking is possible. We know that downgrading attacks is possible, so tricking the network into thinking that you only support an old protocol and therefore you cannot deploy any security measures. Then we have denial of service and fraud, that works nicely. SMS one-time password interception works also. And we can modify the subscriber profile in the databases, so in the MME and in the HSS, and by that we have to see we can do probably data interception. I hope it will be accepted. Then I'm going to present that at the Chaos Computer Club at the end of the year. So we tested this whole thing. So it's not that we are just sort of talking theoretically. Well. Can you hear that? No. Okay. Okay, so this basically means we were the attacker, we were sitting in Finland, and we were using a test network of a friendly operator, a sort of more security progressive. And he had the database, the edge agent, the mobility guy, and we had a phone or a dongle with a SIM card connected to the mobile network there. So and this actually, when I press this, do I shoot down everything? Let's see. No, good. So we had this test network set up, and first what you need to do is to get you get some sort of little touch of code here. So the mobile phone network internally doesn't use your phone number. You have the MSISDN, the phone number, but mobile networks internally, they use something called IMSI, International Mobile Subscriber Identity. And what is that? This identifier is needed for attacks. What this means is that you need to get it first as an attacker. So what you do is actually let's say somebody here in Poland wants to send me, or let's say my mom in Germany wants to send me an SMS. So what's then happening is that the German operator has then an SMS with a phone number, with my Finnish phone number. So it doesn't know where to deliver it. So it calls the Finnish operator and asking, hey, I have this SMS here. Where can I deliver this? Yeah, and the Finnish operator would say, hey, Silke is in the moment in Poland. Here's the node that takes care of her, the address of the node, and here's her IMSI. So that's exactly what this message is about, this SRR message. It's for delivering SMS, so that the German operator, where my mom sent the SMS to, can then deliver directly to the Polish operator the SMS. So that's how it's working. And this basically requests sort of where to route and what's the identity. But for an attacker, that's a perfect opportunity to see my serving node. In that case, he would immediately see that I'm in Poland, and he would get the IMSI, which is needed for any other sort of attack. Here we have a simple attack for denial of service. Actually, that's the most simple attack you can imagine. And we say, send a cancel location message. So a cancel location message is usually sent if you don't pay your bills. So the value 2 here means you don't pay your bills. So this has a quite concrete meaning. And what we do actually, we give it a little twist just to have fun. That we do set this flag here, 3, which means we ask the phone to reconnect, even if it doesn't make sense. So we detach the phone first, and then we sort of reconnect it again. And the reason why we are doing is that we basically run a small denial of service attack against the network. And here we have some brief Wireshark. That's my colleague Banhu Kotte, who has been taking care of large part of the implementation. So you see there the username, which is there this long number, that's the IMSI of the test network of the friendly operator. We have set cancellation type 2, meaning you didn't pay your bill, and we asked the phone to reconnect, that's the value 3 there. And then we sort of set up, the phone is connected in UK. It was just a Huawei dongle, nothing wrong with Huawei, so that's why you see the Huawei on top there. So we set up the thing, we sent the message to UK. Well, yeah, it takes a bit. So it's a bit small. So, and you will see soon. Yeah, so we used Wireshark to catch the details of the messages, and it catches all the messages actually that are exchanged in the core network at that point of time. So the command is executed, and the Wireshark capture is taken, and now he should jump to the Wireshark part. So it disconnected now. So and now it's connecting again. As I said we asked the terminal to reconnect. And the reason for that is that we have one message where we send a cancel location as an attacker. That's that one. And then there are a lot of messages exchanged for some disconnection, and then there are messages exchanged to connect again, because to connect the phone, you when you arrive with an airplane somewhere and you connect the first time to your network, you notice how long it takes because there are a lot of messages exchanged, and a similar thing happens here. So it's called amplification attack. So you send one message as an attacker, and then you get something like 15 messages on the core network. Imagine you don't do that just for one or two, but for a large range of customers. Then you might actually sort of cause damage to the network. Since this was a test network, we couldn't exactly estimate how big the damage would be in a real network. And of course, the operator didn't want to test us. This is a real network. They will be sensitive about that, let's call it that way. Because we would have connected everybody else along the way. So, yeah. So, that's the problem with the testing denial of service attacks. Location tracking. That's also easy. You just set a flag saying you want the location, and then you get it. So you get it's for synchronization between the home network and a visited network, which is sort of quite sensible because the operator here wants to know what kind of subscription I have and so on. And so, but it gets a whole subscriber profile, but the subscriber profile also contains location stuff. So there we go. And so we cannot switch off this interface because, then it would mean you have no roaming. This is how you do a one-time password attack, actually, in diameter. It's running exactly the same way as for SS7. Okay, there are a lot of errors. So basically what you do is, as an attacker, you first contact the home operator trying to get the IMSI, as I explained before. So you say you have this SMS that you want to deliver. And what you do then, you make a location update. You say, okay, the subscriber is now in my network, so please, anything that you have, please send it to me. Then you go to the internet and trigger the password reset. So there's usually password forgotten, usually need a username. In Twitter, it's trivial to insert a username, so that you actually need to know. And then you get an SMS with the recovery code. And what happens on the mobile phone network side is sort of that the phone network then sees, oh yeah, that person is just traveling, so I need to send this this recovery code SMS to somewhere else. And so it requests exactly where to send that. That is this SRR message there on the bottom. And then, as a nice attacker, I say, please send it here. And then this nice service is doing that. You can avoid this actually via home routing to some degree. But that is not very commonly implemented. Some operators implement it, not everybody. So, and then the recovery code gets delivered to me, and I can insert it then into the web page. And these are some of the also Blizzard Entertainment uses SMS recovery code, if I recall right. So, so these are some of the services that use these. I mean, you're pretty sure everybody of you knows some more services that use SMS for password recovery. So Christmas is coming. Amazon shopping. So let's go shopping. But on the convergence between new tricks and old tricks, this is an internet type trick. And the internet type trick is you insert the sender address twice. Why would you do that? So the thing is that you put the sender address twice, and the edge agent then checks, okay, is this guy on the white list? And the first value is a partner operator. So it says, yep, it's a partner operator, marvelous. I push this message through. So it just searches for the first entry, sees it's okay, and then pushes it forward. It doesn't check if there's a second entry. And then the end node, the HSS in that case, what happens there, it's seeing it. The HSS processes the whole message, and what happens then is that the second value overrides the first value. So the answer message is actually routed to value 2. So that's a way to bypass, for example, whitelists if they are not properly implemented. So this doubling trick is actually a sort of internet-style trick. So, but it also pops up nowadays in phone networks. So that's where the two worlds sort of coming closer. I will briefly go to IoT because I think I will soon run out of time. And so IoT, yeah, it's a lot of business to business. So we saw the metering and fire alarm things, connected buses, highways, cars, whatever. So you might say, okay, what do have those to do with roaming? A, they are connected, and B, there's another reason why many of them are potentially roaming. That's not obvious. And the reason is, let's say Vodafone here in Poland, a very big operator. And now Vodafone wants to offer to, let's say, a Polish electricity company that they put for all meters this kind of constant monitoring into the meters. Now meters are sometimes in the basement, so they might not have a good connection. Now Vodafone wants to get the contract, and what they do is they put a SIM card from a foreign Vodafone in there. Why should they do that? And the reason is that they then can go back and to the metering company and say, we offer that these things can connect in 100% of the cases. Because for 99%, the meter will then connect to Vodafone Poland. But in the 1% case where the coverage is just so lousy, it would pop up as a roaming phone and connect to some other operator. Because with a Polish Vodafone SIM, you would not be able to do that. And the billing is just an issue between company internally. They can handle that. Another reason for many IoT roaming devices, and a meter is built in a house, so it doesn't really move, usually. Well, houses usually don't move. So another reason is things like Apple iSIM. Apple is not having a contract with 200 operators. What they have is a contract with one operator who has contracts with a lot of other operators. So it's called broker SIM, this kind of concept. And actually, in technical terms, it looks like a roamer. So even if you never leave your country, it still sort of pops as a roaming. So there are reasons why IoT devices might be suddenly roaming devices, even if they are sort of hard in a house. So we have all these classical interconnection risks, also for IoT devices like location tracking, fraud, and so on. And there are also some, I love this. This is my personal favorite attack. That's arming and disarming a burglar alarm in a house via SMS. I just wait for the extension when you unlock the door. It's just really it's hilarious, isn't it? As a sort of burglar, you just go there, drive in front of the boop, 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 and it's done. Nice. Yeah, well, I suppose you have to wait for some incidents before this sort of stupid thing stops. So the trust model actually for IoT is very similar. So, and also the thing is that now with the electricity company, they want to manage their subscriptions themselves to some degree. So it's slightly different than in a consumer case where you talk directly to your operator. So these are then talking either to some virtual network operator, which are sort of intermediates, or they want to have their own interface. So which means they get their own interface. And this are this red line there. That's the classical between the home and the visited network. And so we get new interfaces here, this T6AI, this T7. These are existing interfaces, and on top there's two new SMS interfaces which might also pop up on the roaming. So which means that there are new interfaces opening up, which means new attack vectors. So situation is bad, and it's, well, we have to learn and develop new approaches, and that's where security research come in. So we need IoT-specific smart filtering on the edge of the networks. Well, countermeasures. Immediately, as IT persons, let's use IPsec. Oh, well, it's not that easy. It's not all IP yet. You won't believe it. And sort of the question is of who would be trustworthy to host a root certificate? Russia, China, mentioned some, and I'm pretty sure there's somebody else who doesn't trust them. Developing countries, they just don't have the money or expertise, they don't care. Also, you would just have hop-by-hop security because of routing issues. And also, it wouldn't protect against some service companies, hacked nodes, bribed employers maybe also, and governmental ties. So it's only sort of some IPsec, it's not a silver bullet, but it might sort of be part of a complete solution. So what do we have on solution space? We can monitor the traffic. We can do penetration testing. We can check what the tenants, the mobile virtual operator, are doing. We can share the experiences. Maybe with a bit of luck, we see something like IPsec with partners in a region, because most of the traffic will be with neighboring countries. That's the nature of roaming, that usually travel not to neighboring countries. So maybe we will see something on that for you. I'm strongly working on that, talking with Inisa. So that means also cooperation with legislators. We can mitigate, we can filter, we can do home routing, we can have this signaling firewall that maybe understands that if you don't pay your bill, you don't need to reconnect. So the signaling firewall means that it's smart enough to know and understand the protocol, what it should do or not do. And there are sort of some standards also for node hardening. So GSMA is working on it. That's the operator organization, but not all operators are equally. So summary. Interconnection attacks are real, but the main focus is SS7. I've seen the first official logs for some interesting diameter attacks. Diameter similar, functionality similar, attacks not exactly the same. Some tricks can be played. It's more IT-ish. Security is not part of an operator business model, never forget that. So, but the risk is just too large for ignore. That's also why governments come in. On the question, it's independent if you have an iPhone, if you have Android, if you have Windows, and doesn't matter. So, and if we don't do anything, people have a problem. Yeah, that's it. Intro to interconnection security. Thanks a lot.
Thank you, and we have some time for questions, of course. So if you raise your hand, either me or Bartek are going to approach you with the microphone. Okay, one question over here.
On one of on the earlier slides, there appeared something that said that it was an IPX network. Is it the same IPX protocol that used to be used in the early internet? In the 1980s, there was a protocol called IPX SPX.
No, IP is just it's an IP interconnection, so that's what the X is for. So.
And my second question, actually not much of a question, just a general topic for discussion. It seems like the network, the roaming interconnection network, was created really without any security in mind, because all the security was practically its obscurity, because nobody knew about it.
Yeah, exactly.
There was no need for security. So do you think that it would be different if it was developed as an open network, as an open standard from the very beginning?
I mean, the standards were open from the beginning. So the standards were available pretty early. So it was just that the real access to the network is restricted. So just sort of really who could connect. I mean, if you think about the ARPANET, the early times of the internet, it was the same. If you had username, password, you were in, you could connect to each node. So, and that changed over time. And I think the same learning curve we see here actually for mobile phone networks. Just it's on a much, much bigger scale because it's connecting so many users.
Okay, thank you.
Okay, we have next question here.
Do you have any recommendations for ordinary subscribers like any one of us?
Well, if you... I mean, I actually know which operators are sort of spending a bit more on money on security or not on, but I think for the user it's extremely difficult to see. So, yeah. No, actually I don't have a good recommendation for users. So, but I think the European operators are much more security aware than, let's say, other regions of the world. So, and I think they are getting more and more awareness. So we really try to educate also operators on what's really out there. So, well.
No, but I mean some recommendations like use a separate phone number for one-time
I mean, for
passwords.
No, but it's useful if the password tool offers it, that there is, if you have this kind of app system, that you have an app on your phone for this, let's say, game or whatever you have, and that you basically get then over the data connection, which is end-to-end encrypted, then the password set
so
to your
no
phone.
SMS.
No SMS,
Use
yeah,
other
exactly.
tools. Okay.
That's actually interesting. In the NIST recommendation, in the draft, the SMS was not recommended for security services, and then suddenly it vanished out of the final version. It was also quite interesting. I don't know how that got dropped, but I don't think it was an accident. So, nevertheless. Yeah, but if there's a possibility to have this app and use this app for getting a password reset, I recommend that. So.
Any other questions? Last call.
Too low. Yeah, well, I think so.
Can you elaborate more about why having separate phone for passwords is not so secure option?
Well, if you don't share that number and nobody knows that this number belongs to you, then this might be a way. But do you really want to? But as soon as you share this phone number, I mean, if you have a dual SIM phone, actually, that provides some sort of security because there's actually a different IMSI connected to each SIM slot. So a dual SIM phone with a secondary subscription, which you never use for anything else, provides some security, but that means also you have two subscriptions and pay for two subscriptions. So it makes some sort of sense, but it costs you money, and you would need a sort of either second phone or a dual SIM phone, which are not that common in Europe. I have a dual SIM phone.
Okay, we have next question here.
It's not quite a question, but I wanted to say thank you for not staying in academia and writing papers that don't end up changing anything, and also thank you for not working for some Saudi company that probably pays way, way, way more than you earn right now.
Yeah, black is not my color.
Yeah, like on behalf of people that don't want to
Yeah,
get
I'm sort of a
hacked.
white
Thank
hat
you.
hacker, sort of trying to improve firewalls and things like that. So I haven't given up hope yet, so let's hope it stays that way. So thanks a lot.
Okay, do we have a last question? In the back.
Somewhere in the dark over there, so. Should I get
How am I exposed if I use only end-to-end encryption?
If you use application layer end-to-end encryption, even if your data session is hijacked, the worst that can happen actually is that the connection is completely broken, but the end-to-end encryption is not broken. So if you don't have this password reset, then it's sort of okay. I mean, if you really have this kind of tremor or signaling or I'm not sure about WhatsApp, so that's okay. Yeah, it says end-to-end encryption, but let's say I don't know who actually has the keys. But at least from technical point of view, if they really have the end-to-end encryption and don't hand out the keys, it should be secure. So even if your data session is hijacked, they just get garbage. There's one further question.
We have one in the front.
Yeah.
Okay.
Just from a user advice perspective, do you recommend SMS TANs on your bank account?
No. No. Actually, there was an MTAN, the mobile transaction number incident for a bank in Austria or Germany. And actually, the operator reacted quite fast, so they found this within 24 hours. And stopped it, but still there was some financial loss. But they were already sort of security-aware operators, which sort of were screening their logs and so on, and they found it actually, so pretty fast. I think 24 hours not too bad for a mobile phone network. But still, they are possible. So I wouldn't recommend SMS as a delivery service for sensitive data. It was not designed for that. It was just some space in the protocol that they used. And okay, let's use it for sending messages. So it was never designed as a secure delivery service.
Silke, do you have any closing remarks, or would you like to take the applause?
I think people want to get home, so so thanks for coming and staying that long. So hope you learned something about mobile phone networks.
Thank you. Silke Holtmanns.